So let's kick it off. Hi, everyone. My name is Courtney Brown, and I'm a senior marketing manager here at EDB. I'll be your host today for our webinar, Deploy Postgres with Confidence in the Cloud. I'm joined by Julien, Postgres Performance Engineer. Before I turn it over, though, I'm going to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast to the email that you used to register for the session. All of the lines are currently muted. If you do have a question, please feel free to submit it in the question panel that you'll find within the Zoom interface. We expect the presentation to last most of our time today, but we'll allot any extra time to Q&A. If we don't have time to address all of your questions, we'll be sure to follow up personally with an answer after the webinar. And without further ado, I will hand it over.
Thank you, Courtney. Hi, everybody. In this session, we will start with an introduction to EDB. Then we will talk about EDB reference architecture, about Ansible and Ansible collections that will help us to deploy the reference architectures and how to deploy them in EAS clouds. Let's start with a few words about EDB. EDB is the world's largest provider of open source Postgres-based software, services, and support. EDB is a major Postgres community leader, founded in 2004, and have now over than 5,000 customers and 28% of the Fortune 500. We have more than 500 employees, and EDB is recognized as a leader in relational database management systems by both Gartner and Forrester. And EDB has acquired second quadrant in September 2020. With second quadrant acquisition, EDB team includes more than 300 Postgres technologists, 26 Postgres community contributors and committers, including founders and leaders like Michael Stonebreaker. Dr. Stonebreaker is the father of Postgres and EDB advisor who created Postgres as the successor of Ingress when he was working and teaching at Berkeley University. Bruce Momian is a co-founder of the Postgres development group and core team member and EDB employee. Peter Eisentraut is a core team member of the project and EDB employee. Robert Haas is a Postgres committer, major contributor in wide areas like query parallelism and EDB employee. And Simon Riggs is a major contributor. He worked on the point-in-time recovery feature and streaming replication. Simon is a second quadrant former CEO and EDB employee. So let's continue with some Postgres reference architectures. Reference architectures are pre-designed, tried and tested templates and deployment patterns for users. The reference architecture can be defined as different levels of abstractions of the deployment as a starting point. Intent of the Postgres reference architecture is to give guidance on Postgres initial deployment based on the business continuity plan. Users can quickly try the reference architecture as it is, or they can use it as a foundation for their deployment. It is based on core architectures of the database server, and add-on architectures provide additional capabilities. In the next slides, we will see three different architectures. The first one is the EDB Array1 reference architecture and is based on a single Postgres instance. In order to ensure good writing performance, Postgres WAL file and data files are located on two different volumes. Postgres monitoring and administration capabilities are provided by Postgres Enterprise Manager. This reference architecture includes backup and recovery capabilities relying on environment usage. Archived WAL files and backup files are stored on a dedicated server. This architecture has not been designed for mission-critical applications. Only one Postgres instance is involved, meaning that it does not provide high availability. So in case of failure of our Postgres server, a new virtual machine must be provisioned, and depending on the failure, volumes can be attached or the data should be restored from a backup. The second reference architecture is edb-array2, and this architecture extends edb-array1 capabilities by providing two additional Postgres standby nodes. Data are replicated through the streaming replication protocol, and to minimize data loss in case of failure of the primary node, quorum-based synchronous replication is configured, meaning that each transaction writing data on the primary node will be committed only after the data has been written on the standby disk. So in case of failure of the primary node, the Enterprise Failover Manager tool is in charge of promoting the most up-to-date standby node, which is the one configured as synchronous replica in this case. When this architecture is deployed in cloud environment, Postgres nodes must be located on different availability zones to ensure high availability. And the last reference architecture is edb-array3, which extends edb-array2 by providing additional connection pooler capabilities with the help of the pgpool software. So in addition to bring connection pooling feature, pgpool is able to balance read-only queries across all the standby nodes, thus offering the possibility to improve read scalability by adding more standby nodes. In this reference architecture, Enterprise Failover Manager is integrated to pgpool in such way that in case of failure of failover, switchover, or when a standby node is offline, EFM is able to communicate with each pgpool node and apply the changes on cluster topology. The client's application do not have to know which Postgres node is the primary node. pgpool will forward write queries to the right node. In this scenario, we have three pgpool nodes deployed in three different availability zones. In case of failure of the pgpool nodes they are connected to, the applications should be able to reconnect to another pgpool node. So far, we have seen three reference architectures that will give some guidance. All of these reference architectures involve at different levels multiple components like monitoring solution, backup and recovery capabilities, high availability, etc. We are now going to cover some tools that will help us to deploy this reference architecture. The first of them is Ansible. Ansible is a very popular and powerful deployment automation tool based on a declarative approach, meaning that we have to describe the state of the components we want to deploy or configure. Ansible does not require to have an agent running on the target host, but relies on SSH connection. Ansible is an open source project managed by a Red Hat company. It brings four levels of abstraction. The first level is a task. A task is a single action that could be like install this package or update this configuration file or start this service, and etc. And then we have a task list, which is a list of actions or tasks. The third level is a role. An Ansible role is a set of task lists grouped by the same subject. This is a way to group tasks together. And finally, we have the playbook level. An Ansible playbook is a list of plays, each operating on possibly different host groups and applying several roles or tasks on this host. to help developers to share their Ansible roles and users to reuse existing roles. Ansible allows to package playbook, role, and plugin into Ansible collections. At EDB, we develop and maintain the EDB Postgres collection with the objective of making Postgres easier. This Ansible collection helps users and DBA to deploy Postgres and its required components. So with this collection, we are able to deploy a single Postgres instance as well as multi-node cluster and streaming replication. We can configure high availability and automatic failover based on EFM. We can deploy a backup server and configure Postgres node for backup based on Barman. We can deploy several connection pooler nodes. We support PG Bouncer and PG Pool. And we can deploy an administration monitoring solution relying on Postgres Enterprise Manager. This EDB Postgres collection is open source, and you can find its repository and bug tracker on GitHub. And each new release of this collection is uploaded and shared on Ansible Galaxy platform. Ansible Galaxy is an online platform used to share collections and roles. On its web interface, we can find some details about the roles and plugins included into the collection. And we can find documentation and instructions on how to install the collection. Installing this EDB Postgres collection on your local machine is straightforward and will be achieved in one command line with the help of the Ansible Galaxy command. This command will download the collection from the Ansible Galaxy platform and install it. Ansible Galaxy command is part of any Ansible package. And once the collection is installed, deployment of the reference architecture can be done using one single command with the Ansible playbook command. So in this example, we specify the path of the playbook file. We specify the path of the inventory file with the -a option. And we can specify the username for SSH connection via the -u option. And we can specify the SSH private key to use for SSH connections. Let's talk about the playbook file. So one of the key components of every deployment based on Ansible is the playbook file. The EDB Postgres collection includes a generic playbook file that will help to cover most of the needs. But before you start using it, you will have to make some changes on some of the variables. The PG version variable defines Postgres major version to deploy. So we support from PG 10 to PG 13. The PG tab variable defines the database engine to deploy. This collection supports Postgres Community Engine and edb-pass engine. And we need to define edb yum repository credential with the help of the variables repo username and repo password. By default, Ansible output verbosity is restricted to avoid sensitive data being displayed. So for debug purpose, it could be helpful to turn off this feature by setting the disable login variable to false. The second important key file of every Ansible deployment is the inventory file. The inventory file defines the list of the hosts used for our deployment. Hosts definition are grouped by host groups. This is a way used to apply the same changes on similar nodes. In the EDB Postgres collection, we have several groups. We have the PEM server group, primary group for Postgres primary node. We have the standby group, PG pool group, and so on. Each host group contains one or more hosts. Hosts are defined by a name. In this example, we have temp server 1, primary 1, and standby 1. The Ansible host variable, which is the IP address used by Ansible SSH connection, and the private IP variable, which is the private IP address of the node. If we have only one IP address available on this node, Ansible host and private IP variable should be configured to the same value. And we have some specific variables depending on host group. Now let's take a look at some management capabilities included in the EDB Postgres collection. EDB Postgres collection can do much more than just deploying some of the roles are dedicated to manage configuration and objects. With the help of the manage DB server role, we can manage Postgres users, like create one user or change its password or remove this user, and so on. We can grant specific privileges to Postgres user, and we can grant another role to Postgres user. Still, with the help of the manage DB server role, we can update Postgres settings, we can manage Postgres HBA entries, and we can manage databases and extensions, and we are able to manage replication slots. And finally, with this role, we can execute SQL queries, we can send an SQL file on the remote host, and then execute this SQL file. And we can manage pgpost entries. Okay, so far we have seen 3 different reference architectures and how Ansible can help us to deploy them. Now we are going to see another tool developed at EDB that will mix reference architecture, the EDB Ansible collection, and cloud deployment. This tool is edb-deployment. It's a Python command line interface supporting Python 2.7 and Python 3. It is an open source project hosted on GitHub. edb-deployment is packaged and available on the PyPy platform. So to install it, you just have to pip install it like any other Python software. It works on macOS and Linux platforms. It supports IaaS cloud vendors, AWS, Azure, and G-Cloud. And this tool relies on some external tools like Ansible, AWS CLI, Azure CLI, and so on. So it could be sometimes not easy to install all these dependencies in the supported version. So to ease this step, we provide installation scripts. edb-deployment use Terraform for provisioning cloud resources like virtual machines, virtual network, storage, and so on. Terraform will also be in charge of destroying the cloud resources when we don't need them anymore. Terraform is an open source infrastructure as code software that aims to manage infrastructure. So once our cloud resources have been created, edb-deployment will be in charge to deploy the reference architecture with the help of Ansible and the EDB Postgres Ansible collection. So basically, reference architecture deployment in cloud with edb-deployment will require only 3 steps. The first step is the configuration. Once the configuration is ready, the second step is cloud resources provisioning, and the final step is software deployment. That's all. Let's focus on the first step. So the first step is project configuration. A project is like a namespace that we help us to identify our deployments, because with this tool we are able to deploy multiple environments. At this configuration stage, we have to specify which cloud vendor we want to deploy this project on, the subcommand we want to execute, which is configure in this case, the project name, which reference architecture we want to deploy. We have to define some of the Ansible variables we have seen before, like edb repository credentials, Postgres engine type, and Postgres version. We can specify the operating system we want to be installed on the machines. Default value is CentOS 8. And we can also specify some cloud-specific parameters like cloud region. So once the project has been created and configured, we can move forward to the provisioning step. So the second step is cloud resources provisioning. So this step is quite easy to execute because we don't have any option there. We just need to specify the cloud vendor, the subcommand, which is provision in this case, and the project name. The execution time of this step takes some time and is dependent on the number of virtual machines involved in the target reference architecture. On AWS, it took 5 minutes to provision the cloud resources requested for edb-3 reference architecture. And the last step is the Postgres deployment. So once the cloud resources are ready, we can proceed with the deployment of Postgres and the components. This time again, we have to specify the cloud vendor, the subcommand which is deploy in this case, and the project name. The execution of this subcommand triggers edb Postgres Ansible collection download and installation and Ansible playbook execution. Ansible playbook execution will take some time because there is a lot of components to deploy. At the end of the execution, some useful informations are displayed, like PEM informations and credentials, and the list of the nodes with their IP addresses. And that's it. Our reference architecture has been deployed. So far, we have seen 3 different subcommands we need to run to deploy our reference architecture in cloud, but there are other useful subcommands. List subcommand displays the list of the projects configured for a specific cloud vendor. Display subcommand shows project post-deployment details like PEM information and the node list. The password subcommand shows all the credentials generated during the deployment. And the destroy subcommand is used to delete project's cloud resources. Another interesting subcommand is the logs subcommand. edb-deployment display its log file using this subcommand. So, as we have seen previously, this tool is not very verbose and does not display what Terraform or Ansible are doing under hood. So, instead of displaying tons of output, edb deployment stores them into a log file, and the content of this log file can be displayed by the log subcommand. Only one option is available there. This is the -tail. When using this option, edb deployment won't stop at the end of the log file, but will wait for new inputs and then display them in real time And the last interesting subcommand. So the edb-deployment configure subcommand we have seen earlier creates and configures a new project with default cloud resources sizing. If we want to use, for example, more powerful machines or larger or more performant disks, we can achieve this with the help of two additional steps before configuring the project. First, we need to use the specs subcommand for our target cloud vendor and save command output into a JSON file. This file will contain some of the Terraform parameters that will be used during provisioning stage. The second step, we have to edit this JSON file and apply the changes. For example, to change Postgres instance type, we must change the instance type value of Postgres server object. If you want to use the IO2 disk type for pgdata and pgworld volumes, we have to configure the type value of the additional volumes object to IO2. Once our JSON file is ready, we can proceed with the configure step as we have seen before. But this time we have to use the -spec option to define the JSON spec file to use. And that's it. All the tools presented in this session are open source, so feel free to try, test, and use them. Any kind of contribution is warmly welcomed. So if you find any issue or even if you have some questions, so please go to the GitHub repository and please open an issue. We will do our best to help you. And thank you.
Great, thanks so much. So we're going to open it up to Q&A now. It looks like we have one so far that's been submitted, but everyone else, please feel free to drop them in the Q&A panel if you have any questions right now. Also a reminder, we'll be sending out a recording of this session along with a copy of the slides later today, so you'll have this to reference later. But someone wanted to know if this was only supported by specific cloud providers.
Sorry, let me check the chat, please.
Yep.
Okay, about the supported cloud providers, we are currently supporting AWS EC2, as Microsoft Azure, and Google G Cloud. And what about Key Vault support for Azure? Is it currently available? No, not for the moment. Another question: if you already have a deployment on Azure, is there a way to leverage command to display lists the database details or other information? No, this is not possible because when creating a new project, we are actually creating a folder tree, including some kind of inventory files. So this is not possible to use this tool against some already deployed environment. Another question. In Azure, there are several Postgres projects, none of which are edb. Would the tooling described work with this project, at least partially? Actually, the edb deployment script will deploy the Postgres engine of our choice on virtual machines in the cloud. So we are not depending on cloud vendor Postgres versions they can offer in the SQL cloud, but we can deploy the engine of our choice. Does it redirect the connection correctly using pgpool to the primary and secondary node? So yes, pgpool has some special features like parsing the query, and pgpool is able to detect when some really basic queries are some writing or read-only query, or we can add some kind of hints on the client side to specify to pgpool that this query will be a read-only query or this query will be a read-write query. And pgpool will be able, when he knows that the query is a read-write or read-only, to redirect this query to the right node, or the right nodes. Does it need a separate license for AWS to deploy Postgres, or it is covered? I'm sorry, but I don't know about the EDB license in this case. Is there support in for PG Bouncer? So yes, edb-ansible has two roles dedicated to PG Bouncer. The one role is for the PG Bouncer deployment, and the other role is for PG Bouncer management. But so far, we don't have a real integration with EFM. So when we have a Postgres cluster configured in high availability with EFM, when we execute a switchover, for example, in case of PG Bouncer usage, we have to update manually PG Bouncer configuration to apply the changes. So for the moment, we don't have this kind of integration with between EFM and PG Bouncer, but we plan to do it in the near future. With this provision and configuration tool, is it possible to change the state of the storage? For example, will it be possible to add some reference table that was forgotten in the data mart reference and deploy on cloud? I'm not sure to really understand the question.
Okay, that's all right. So the two that we weren't able to answer, we'll circle back with our broader team and make sure that we follow up with both of you.
Okay.
Yeah. So I think, one more question just popped in.
We are using Azure Active Directory to provide active credentials. Will this work with EDB? With edb-EPAS, we have LDAP and Active Directory support, like in Postgres community. So I guess yes, this will work.
Okay, it looks like that's all the questions that have come through. So as I mentioned, we'll circle back with any that we weren't able to answer live, but we wanted to thank you all for joining us today. And Julien, thank you for putting this session together. We hope you all have a great rest of your day. Thank you.
You.
Bye.
Thank you.